Hello everyone, welcome to my YouTube channel. I am Dr. Injamamul Haque, currently working as an assistant professor at the Department of Mathematics, School of Computer Science and AI, SR University, Warangal. In the previous lecture, we discussed about the hypothesis testing for a single variance using the chi-square test, right? So now, today, we take the next step. What if we have two population and we want to compare their variability? That exactly what we are going to learn today, testing the equality of variance using the F test, right? So first we discuss why hypothesis test concerning for the two variance to determine whether the population variance are statistically equal or not, to verify the assumption required for a many parametric test, to identify the difference in variability between two processes or population, and important in engineering, economics, quality control, and scientific research, right? So to do this, we use the F test. Okay. So first we will discuss about the assumptions for the F test. Okay. Assumption for this test, both the population must be normally distributed and the sample must be independent of each other and data should be collected using the random sampling. And observation within the each sample must be independent. And we will use the some notation sigma 1 square we will use for variance for population 1, sigma 2 square we will use for variance for population 2, s1 square we will use for sample variance for the sample 1, and s2 square will be used for the sample variance for sample 2. N1 is the sample size of the first sample and N2 will be the sample size of the second sample, right? So now we discuss about the test regarding the hypothesis testing for variance of two normal population. So here we will use the F test. So to finding the hypothesis testing concerning the variance of two normal population, the step one will be what? Hypothesis formulation. That is, we will take the null hypothesis as a sigma 1 square equal to sigma 2 square. Then we will take the alternative hypothesis sigma 1 square not equal to sigma 2 square for the two tail test. And for one sided or one tail test, we can take that sigma 1 square is greater than sigma 2 square or sigma 1 square is less than sigma 2 square. Now we will use the test statistic formula for this is a called F statistics, right? And the formula will be what? F is equal to the S1 square by S2 square. Usually larger sample variance is placed in the numerator. Okay. The ensure the calculative value of F is greater than or equal to the 1. So this is all about the hypothesis testing. Okay. In step 1, we will determine the hypothesis. In step 2, this is step 1, this is step 1. In step 2 we will find the test statistics, and in step 3 is what? If F calculative value is less than F critical value that can be obtained from the F distribution table, then it will accept null hypothesis H naught, and if F calculative is greater than F critical, in that situation it will reject the null hypothesis H naught. So what things have to do? In step 1, we will we have to determine the hypothesis, null hypothesis and alternative hypothesis. In second steps, we will find the test statistics value called the F statistics, and with the use by using this formula, then in step 3 we will find the critical value of F from the F distribution table. Then we will check whether F calculative value is less than F critical. If it is less than calculative value is less than critical value, then it will accept the null hypothesis, otherwise it will reject. Okay. So the F statistic follow the F distribution, and it is continuously probability distribution. It depends on two parameters called degree of freedom. The distribution is skewed to the right, and degree of freedom for the two normal population can be find at df1 is equal to n1 minus 1 and df2 is equal to n2 minus 1. And this value determine the exact shape of the F distribution, and they are required to obtain the critical value from the F table. This value will be used to finding the critical value for the from the F distribution table. Okay, so now we will discuss first problem. Problem 1, a psychologist was interested in exploring whether or not male and female college students have a different driving behavior. The particular statistical question she framed was follow. Is the mean fastest driven by the male college student different than the mean fastest speed driven by the female college student? The psychologist conducted a survey of random n is equal to 34 male college students and a random m is equal to 29 female college students. Here is the descriptive summary of the result of her survey. Okay, so you can see that this is the table for the male n is equal to 34, female m is equal to 29, x bar is equal to 105.5, y bar is equal to 90.9, sx is equal to that is 20.1, sy is equal to 20.2. Is there sufficient evidence that alpha is equal to 0.05 level to conclude that the variance of the fastest speed driven by the male college student differ from the variance of the fastest driven by the female college student? So now let us check. So now in this question what is given? Given is what? Sx is equal to 20.1. So this implies Sx whole square, this is equal to 404.01. Sy, this is equal to the what? 12.2. So this implies Sy whole square, this is equal to 148.84. Okay. And what is n? N is equal to the 34 and m is equal to what? 29. So now in step 1, in step 1, in step 1, what is that? In step 1 we will formulate for the hypothesis. So null hypothesis H naught is equal to what? Sigma x square is equal to the sigma y square. What is the alternative hypothesis? HA, this will be sigma x whole square not equal to sigma y whole square. Okay. So in step 2 we will find the statistics value. Now in step 2 we will find the f statistics value, f calculative value. This is equal to the what? S1 square by sx square by sy square, right? So this is equal to the what? 404.01 by 148.84. So this is equivalent to 2.71. Okay, this is equivalent to 2.71. And now in step 3, we will find the f critical value, right? So in step 3 we will find the f critical value, and here alpha is equal to what? 0.05, and that will be divided by 2 because this is 210 test, right? So we will find the f critical value. This is equal to the what? F alpha by 2, f alpha by 2, f alpha by 2 comma n1 minus n minus 1 m minus 1. So this is equal to the what? F 0.025, 33 and 28. So this is equal to the 2.10. 2.10. So what things we have found here? So here we found that if calculative value is equal to 2.71 is greater than 2.10, this is f critical value. F critical value. F critical. So it will reject the null hypothesis. Okay. So that means what? The final conclusion about this problem is what? At alpha equal to 0.05 level, there is sufficient evidence to conclude that the variance of fastest speed driven by the male and female college student are different. That is, male student not only have a higher average fastest speed, but their speed are also more variable compared to the female student. Okay. So now you can solve this another problem. This is also based on this F test. Okay, so you will solve this problem, and These are the problem. A company uses two different machines. To there is another problem. You can practice based on the F test, right? These are some exercise question. You can solve this. Okay. If there is any doubt, you can post a question on the comment section. And if this lecture help you to understand the concept clearly, make sure to like this video and subscribe to channel and share it with your friend. And also in the next lecture, we'll move on the step ahead into the another important topic in statistical inference. Until then, keep learning, keep questioning, and keep exploring mathematics. Thank you so much. Thank you. We will meet in the next video. Thank you.